Welcome to Chapter 11 in Math 95. In Chapter 11, we're going to take a look at the study of quadratic functions and equations. Specifically, in Section 1.1, we're going to look at a couple different ways of solving quadratic equations. The first method will focus on just kind of getting x by itself and then seeing what we get on the other side. Another method, which is going to be more complex, is going to involve something called completing the square. And the first set of problems here helps to lead us to all the different skill sets that are going to be needed in order to effectively complete the square of a quadratic equation. So what makes an equation quadratic is when you have a term in it that's raised to the second exponent. We have a variable that's going to be raised to the second exponent. So if you have something like x squared plus 3x plus 2, and let's go ahead and set that equal to 0 to make that a quadratic equation. It's the x squared term that makes it quadratic. If you have something like 3x minus 2 equals 2y, this is something that's going to be simply linear. Okay, so these are different to each other. So we'll go ahead and then we'll take a look at how we solve quadratic equations here. Let's begin by looking at question 13, and we'll dive right into this. So we have x squared is equal to 100. Now, one thing that we learned about in chapter 10 is that when we take the square root of a number, that we only identify its positive value. However, when you are taking the square root within an equation, we can identify both its positive and its negative value. So if I were to ask you very simply for the square root of 100, we would simply identify that the square root of 100 is 10. But if we have the quantity of x squared equaling 100, and I take the square root of both sides, we can identify the value of x as being equal to both positive 10 and negative 10. This is one notation we use to identify that this is both positive and negative 10, which simply goes to represent the two different values that we obtain there. So this is just a notation to show that there are two different values of x that make the true, positive 10 and negative 10. So we can obtain negative results as we solve these type of questions. Let's go ahead and take a look at a question like 15. So this is going to be p squared minus 50 is equal to 0. So in this problem, we have a couple things to do. Other than p squared, there's just a number in this problem. So we're going to go ahead and we're going to get the p squared term by itself. Now, that's not always going to be the case. Sometimes we are going to want to get the p squared term by itself, the x squared term, or whatever variable is raised to the second exponent by itself. And then sometimes we're going to want to set the whole quadratic equation equal to 0. We'll draw up those distinctions as they come up. But for now, let's go ahead and get p squared by itself. So I'm going to add 50 to both sides. And that's going to give me p squared is equal to 50. So at this point, because I have p squared by itself, I can square, or take the square root of that side and get p. And that's what I want. If I do that now, the square root of p squared will be p. Remember, if you're taking the square root on this side, it's going to be both plus and minus, so you want to make sure you kind of identify that first. And now it becomes a question of simplifying the square root of 50. Hopefully most of you know that I can rewrite the root of 50 as being equal to 25 times 2, or that I can write the square root of 50 as 5 radical 2. So our final answer for the values of p is going to be plus 5 radical 2 and minus 5 radical 2. So there is this step here in getting p squared by itself so that we can take the square root of both sides and get p alone. Let's take a look at another example, maybe slightly simpler. This is going to be 16, and this is c to the second minus 8 is going to equal 0. Again, I have a c squared term and I have just a number. I can go ahead and let me add 8 to both sides. This is going to give me c squared is equal to positive 8. And because I have c squared only here, I can take the square root. I can take the square root. The square root of c squared will be c. And then the square root of 8 is going to be plus and minus. Well, that's going to be 4 times 2. So this is going to simplify to 2 radical 2. So the values of c are going to be plus radical 2 radical 2 and minus 2 radical 2. Let's take a look at another problem that has maybe a little more intricacy to it. Let's take a look at question 20. So here we have x squared equals negative 9. Now, if we take the square root of both sides of this problem here, and by the way, you may want to write this separately. Go ahead and do so. If I take the square root of both sides, in the past, when you've been asked to do this, you've been told, oh, well, there's no way to do this. There's no real answer. So remember, we've been learning very recently about that imaginary numbers exist. And imaginary numbers are not real numbers. So it's still going to be plus and minus, but we all know that the square root of 9 is equal to 3, and that when we have a negative underneath, it's going to come out as an I, because the square root of negative 1 is equal to I. So we write down the answer for the value of x as being plus 3i and minus 3i. There are two solutions. They are both imaginary numbers. Let's go ahead now and take a look at 22, and let's see what we do in this type of problem. So in 22, we have 25x to the second minus 4 is equal to 0. So in this problem, I'm going to go ahead and add 4 first. When I do that, that's going to give me 25x squared is equal to 4. Well, I could take the square root of both sides at this point, but you really should try to get the x squared term completely by itself. So I'm going to go ahead and divide both sides by 25, divide both sides by 25. And at that point, it's going to give me, and I'll bring this up over here, x squared equals 4 over 25. So I'm just going to bring this up here. So I have x squared is equal to 4 over 25. And much like the work we learned about in Chapter 10 when we simplify something like this, I can now take the square root of both parts, and I can write this now as x is equal to plus and minus. The square root of 4 is 2. The square root of 25 is 5. So my two solutions of this are going to be plus 2 over 5 and minus 2 over 5. So remember, there are two solutions to this. So bear in mind that when you're doing this type of work in MyMathLab, it may ask you to write the solutions, or might ask you to write the solutions in different types of notation. So be careful to look for that and ask questions in class if you have any. We're going to kind of expand to one more question similar to this before we go to the next part here. So let's take a look now at 26 to a question that's pretty similar, but maybe with a little added twist. So 26 is going to read 25y to the second plus 16 is equal to 0. So again, if I can get y squared by itself, so that's the only y in there, I'm going to do that. So let me subtract 16. This will give me 25y to the second equals negative 16. Next, I'll go ahead and divide both sides by 25. That's going to be y squared equals negative 16 over 25. I'm just going to put that negative in the center there. Now that I have y squared by itself, I can take the square root away from both sides. That's going to give me y is equal to plus or minus, well, let's see. The square root of 16 is 4. The square root of 25 is 5. The square root of that negative is going to be I. So this is going to be plus or minus 4 over 5 times I. And there is going to be our answer for those type of questions. So just in a very brief introduction of this, we see that we've gotten the variable by itself, but it's not always going to be quite so clean or easy that way. Let's take a look at another example here in question 28. So in 28 we have the value of x plus 2, and that's going to be squared is equal to 25. So in this problem now, what we're going to do to work to get x by itself is take the square root of both sides. So we're going to take the square root of this quantity, and we're going to take the square root of this quantity. When I take the square root of x plus 2 squared, the square root and the square are going to undo each other, leaving me with just x plus 2. On the other side, when I take the square root of 25, again, it's going to be plus or minus 5. So here's where the notation of this becomes important, because we're not going to be able to leave the answer with just this now. Let's take a look a little further what happens. I want to get x by itself, but I still have a plus 2 here. So I need to subtract 2 from both sides. So watch the notation on this and pay close attention. So these are going to reduce, leaving me with just x. This is going to be written as negative 2 plus or minus 5. So I want to identify exactly what those two values are. To do that, I'm going to go ahead and I'm going to split this up into two parts. So I can split this up into negative 2 plus 5, and I can make this negative 2 minus 5. So I'm using the two values of positive 5 and negative 5 here to see what values of x I'll get. When I have negative 2 plus 5, negative 2 plus 5 will give me a value of 3. When I have negative 2 minus 5, that's going to give me a value of negative 7. So we have two possible values for x here. We have x is equal to 3, and we have x is equal to negative 7. So those are the two values that x can be that is going to make this true, the original equation. Let's go ahead and take a look at a few more problems for your consideration. Let's take a look now at 32. So in 32 we have the quantity of x minus 1 squared is going to equal negative 49. So again, I'm going to look, I need to get this out of here. Don't square this. That's just going to make it so much more complicated to try to get x by itself. I'm going to go ahead from this point and take the square root of both sides. When I do so, that's going to remove the 2 from the exponent here, give me x minus 1. Over here, being careful, it's going to be plus or minus. The square root of negative 49 will be plus or minus 7i. From this point, I go ahead and I add 1 to both sides. And when I do so, it's going to give me x is equal to 1 plus or minus 7i. Now, sometimes on some questions, this is the answer that they may look for. They may also look for you to split this up to 1 plus 7i and then 1 minus 7i. So you may have to offer both forms of the answer. So you may need to write this as x equals 1 plus 7i, and then x equals 1, whoops, not a comma here, minus 7i. So there are two forms of the answer. And because we have both of these written in a plus bi form, this is the form that you are going to need to express your answer in. And you'll recall from what we learned in section 10.8, this is a real number, this is the imaginary number. When we put these together, this is what we call complex form. Okay, we'll go over one more question like this just to kind of reinforce this a little better. And let's see where this is going to go. So one more question we're going to look at for this is, let's take a look at 36. Kind of give you a flavor a little more closely where we're going to go with this type of problem. So we have x squared minus 6x plus 9 is equal to 100. Well, what's different about this is a trinomial. It's still a quadratic equation because of the x squared, but we have a trinomial. However, if we factor this, we will notice that we can write this side as the quantity of x minus 3 times x minus 3. We can further simplify this by writing this as x minus 3 squared is equal to 100. Once we get the problem to this point, we can now go ahead, take the square root of both sides, and we would get x minus 3 equals plus or minus 10. At that point, I'm going to go ahead and add 3 to both sides and get x equals 3 plus 10, or 3 plus or minus 10, which is going to give me 3 plus 10 and then 3 minus 10. 3 plus 10 will give me 13. 3 minus 10 will give me negative 7. So we have two values for x, 13 and negative 7. So those are the two possible values for x in that equation. So when you have something like this, you are going to have to do some factoring. And fortunately for the work we're going to do later when it comes to completing the square, we're going to have to manipulate this to be able to write this as the as a binomial times itself, so that we can write it as a perfect square. Let's just take a look at a few examples similar to some of the work we did before. We're going to take a look at 38, and this is a notation issue more than anything. It's going to say let f of x be equal to x squared. And it says to find x when f of x is equal to 11. So it says f of x is equal to 11, and all it's really asking you to do is to put 11 in place of f of x. Now, if for some reason you prefer to have the x on the left and don't like that, there's no reason you can't switch it around. But you don't have to. Just if you prefer it that way because of the work we may have to do later sometimes, you can switch it around. So now I'm going to take the square root of both sides, and x is going to be equal to plus or minus radical 11. We cannot simplify this any further, and we're going to find with a lot of problems that the solutions to these may look a bit complicated. So when you see something that contains a function, all you have to do is sub the value in and just do the kind of work that we've been doing up to this point. So that concludes the first part of this lesson here. We're going to take a look at the next part in a lesson here in coming up part 2.